Remember manual memory management? You had to allocate memory, use it, and then explicitly free it. That third step was the problem. Forgetting to free memory caused leaks. Freeing it at the wrong time caused dangling pointers. Garbage collection is a form of automatic memory management. It's a background process that runs alongside your program. The garbage collector finds memory that's no longer in use and reclaims it automatically. With garbage collection, you still allocate memory and use it, but instead of explicitly freeing it, you just forget about it. The garbage collector handles the cleanup for you. But how does the garbage collector know when memory is no longer needed? It uses a principle called reachability. The collector examines every object in your program's memory and asks a fundamental question. Can the running program still reach this object? If yes, the object is still in use. Keep it. If no, the object is unreachable. It's garbage. The collector can safely reclaim that memory. This single principle is what makes automatic memory management possible. To understand how reachability works, let's use an analogy. Imagine your program's memory as a house with different rooms. This is the living room. This is the bedroom. Each room represents a different area of memory. Different types of data live in different rooms. Now, let's see how the garbage collector determines what's reachable. In this analogy, you represent the stack. The stack is where your program's active execution lives. All your local variables, all your function calls, they're here with you in this room. We call this the starting point for reachability. Everything begins from here. If an object can't somehow be traced back to where you're standing, the program can't possibly access it anymore. Now let's divide our house more clearly. On the left, where you're standing, is the stack. On the right is the heap. The heap is where all your dynamically allocated objects live. Think of these as things you've stored in the bedroom. When you create an object at runtime, it goes here. Here's one object. Here's another. And here's a third one. These represent data structures your program allocated while running. The question is, which of these can you still reach? References in your program are like paths through the house. They connect you to the objects you've created. Let's say your program has a variable that points to this first object. That creates a path. You can walk from where you're standing, follow this path, and reach the object. Your program has another variable pointing to the second object. There's another path. You can reach this one too. But now look at this third object down here. Notice something important. There's no path connecting you to it. Maybe you had a path earlier, but the variable went out of scope. Or maybe you reassigned it to point somewhere else. Whatever the reason, there's no way to get from where you're standing to that object. The program cannot possibly access it anymore. This is what we mean by unreachable. Now imagine the garbage collector as a cleaning crew that periodically walks through the house. Their job is systematic and methodical. Let me walk you through their process. First, they start from where you're standing in the living room. This is their starting point, just like it's yours. Second, they follow every path they can find. They walk down the first path and mark that one as reachable. They walk down the second path and mark that one too. They explore every possible route from your starting position. Third, after exploring all the paths, they look at what they've marked. These marked objects are the ones the program can still reach. These are live objects that need to stay in memory. Fourth, everything else gets cleaned up. That third object with no path, it's garbage. The collector removes it and returns the memory back to the heap for reuse. This process repeats automatically as your program runs. You no longer have to worry about memory leaks. If you stop using an object and lose all references to it, the collector finds it and reclaims the memory. No more dangling pointers. As long as you can reach an object through any path, the collector keeps it alive. It won't be deallocated while you're still using it. As a programmer, you just allocate and use memory. When you're done, you simply stop referencing it. The garbage collector handles the cleanup automatically. No more tracking which objects to free, no more worrying about when to free them. In our next lesson, we'll explore the first algorithm that implements this idea: reference counting. Subscribe, like, and share.